Chapter 14, chi-squared. I did a video on chi-squared test of independence, if two things are independent or not. That is where you have a table and you're testing to see if one thing affects the other or, are they independent of one another. Today we're going to do a goodness of fit test. And people ask me, how do I know which test to do? Number one, you look for a table. Is it a 2x3, a 3x3 table? That's a test of independence. The problem we're doing today, I have certain categories. And there's a claim that says that all the categories are either the same, or the problem we're going to do now is there's supposed to be a certain percent in each group. So I got numbers up here that a large distributor of gasoline claims that 60% of cars use unleaded, and 20% use regular, and 20% use super unleaded. So this one is not every category is the same, but a certain percentage. So the claim is this is 60%, this is 20%, and this is 20%. And then they collected some data, we'll assume randomly, and they got 400 cars, I believe, and 51 were regular, 261 were unleaded, and 88 were super unleaded. So, here we go. Step one, name the test. This is a chi-squared goodness of fit test. It's supposed to follow a certain pattern. They're either all the same, or in this case, there's a certain percentage for each category. The null hypothesis is gas is sold according to the claim. Or you might want to write the large distributor's claim is true. The large distributor's claim is true. So the alternative would be the gas company's claim is not true. So is not sold according to the claim. There's a couple ways of writing it. So this one is also, you just throw a not in there. The gas is sold according to the claim, or the gas is not sold according to the claim. The claim is true, or the claim is not true. Step two is we need to see how the data was collected. We'll assume randomly, and there is no normal check. Normally, there's a normal check. It's a good joke, isn't it? Normally a normal check. But in this case, all we need to do is see, did we collect a big enough sample? So we normally need to look at the expected counts. The numbers up there are not the expected counts. Those are the observed. That's the data that was collected. They're always going to give you the observed on the AP tests. On your project, you're going to collect data. That will be the observed. So this is the observed. 51 cars got regular, 260 cars got unleaded, and 88 got super unleaded. So now we do need to find the expected counts. So first thing is we find the total. Some goodness of fit tests say that each category is the same. So you would take 400 and divide by 3. Or they say that there's a certain percentage in each. In this case, we have to find 20% of 400. 20% of 400, you take 0.2 times 400, and that gives us 20%. Oops. 0.2 times 400 gives us 80. So there's supposed to be, we expected 80 regular, and also 20% over here is supposed to be 80 for the super unleaded. The rest are the just the unleaded, and that's supposed to be 60%. So 60% of the total. 60% of the total. So that is 0.6 times 400. That gives us 240. So now we have our observed and our expected. So this is a little off. This is not exactly where it's supposed to be. That was supposed to be 240. It was actually 261. This is supposed to be 80. That's kind of close to 88. But is that too far away? Is our observed too far away from our expected? Or could that simply happen by chance? That's what we're going to figure out. So now step 3. Step 3 is plugging and using our calculator. So we hit stat, test, and we're going to go to goodness of fit, enter. And this one, oh yeah, we have to put in the data into a list, not into a matrix. A matrix is a test of independence when you're given a table. So we need to enter our numbers into lists. So we go stat, edit, and I'm going to put the observed in list 1. So I go up to L1, hit clear, go down, observed is 51 to 61 and 88. And over here are the expected counts, which we just calculated. 80, 240, 80. And now we go and run our tests. Stat, test, chi-squared, goodness of fit. And we do need to make sure that we have degrees of freedom. Degrees of freedom are number of categories minus 1, so that would be 2. 3 minus 1, 2. Calculate, and we get our p-value. Our p-value is like 1%. We write everything down. We write down chi-squared is 13.15. P-value is 1%. Degrees of freedom is 2. We also have to write down part of the formula. So part of the formula would be 51 minus 80 squared divided by 80 plus dot 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 the last one. 88 minus 80 squared divided by 80 divided by 80, and that ends up equaling 13.15. So that's step 3. I don't think I talked about step 2. Step 2, all expected counts greater than 5. Yes, we listed the expected counts. They're all greater than 5. We're good to go, so make sure you mark that down. Step 4, I'm not going to write it out since we have good practice. It is actually not 1%. I am wrong. It's 0.001, so it's very low. Could we got the results we got simply by chance? Nope, we could not. We would reject the null hypothesis because the p-value is very low. So we have evidence to say that gas is not sold according to the claim. And that is your goodness of fit test.